Today I want to tell you about the metal neodymium. It is one of the metals of the lanthanides and is located at the bottom of the periodic table of chemical elements. Neodymium is a fairly active metal, which is stored in glass ampoules or in an inert atmosphere for corrosion protection. In air, it will oxidize and cover itself with a layer of oxide. Immediately from the ampoule, neodymium can be seen as a shiny metal with a distinct crystal structure. Neodymium is a relatively hard metal. Its hardness resembles iron. I even broke the pliers, trying to bite off the piece of neodymium in half. Also, while experimenting with neodymium, I noticed that when you tap on it, the metal produces a running sound, just like bronze. This is telling us of the elasticity of the metal. Neodymium dissolves well in hydrochloric acid, and the reaction goes very rapidly. During this reaction, it produces hydrogen and neodymium chloride, which is of pink color, like the many of the compounds of neodymium. The solution of neodymium chloride has one amazing property. Its color can be different depending on the lighting. When under the illumination of a LED lamp, the solution looks pink, but under the light of a fluorescent lamp, the solution becomes yellow. This effect is caused due to the presence of F electrons in the outer electron layer of neodymium. The light absorption spectrum of the compounds of neodymium has very sharp bands, caused by so-called forbidden FF transition within the metal's atom. If I got anything wrong here, please do correct me in the comments, as I'm not very good in quantum physics. This property of the compounds of neodymium is used for the production of so-called neodymium glass, which is used in photography as filter of yellow light. Also, this glass is used in incandescent bulbs to create a more white light. If you add sodium hydroxide or light to the neodymium chloride, the precipitate of neodymium hydroxide is then produced, which, like all the neodymium compounds, change its color depending on the lighting. From this compound, it's possible to make neodymium oxide by using heating, which is added to neodymium glass for the manufacture of heavy-duty lasers. These lasers are used to create fusion synthesis. They have an extraordinary power. The neodymium chloride can be dissolved in Trilon B, that's used to remove limescale in kettles. It looks very nice if we look at it with a macro. Neodymium can also react with acetic acid by dissolving in it. As with lanthanum, in this reaction a suspension of neodymium hydroxide is formed. If you heat the neodymium with a gas burner, it will not light up due to its high melting point. However, the neodymium powder burns perfectly on air. Metallic neodymium is attracted to the magnet quite weakly and is paramagnetic. However, in combination with iron and boron, neodymium obtains an incredibly high ability to magnetize, so-called magnetic saturation. Using this property of the compound of neodymium iron boron, it is used for the manufacture of the most powerful to date neodymium magnets. These magnets are now used everywhere, from hard drivers to expensive speakers. Also, I would like to note that these magnets are very fragile. The neodymium iron boron compound resembles ceramic, so these magnets are very easy to break or crack. On the outside, these magnets are coated using nickel for protection from corrosion. Now you know a little bit more about one of the other metals. If you would like to support the continuous production of science videos like this one, please support channel on Patreon, link in the video description. Please like this video and subscribe to my channel to see many more new and interesting